Good morning to all of you. I hope I am audible. So, in today's class, we will start with one new topic in engineering mechanics, and that topic is Dalembert's principle. And this Dalembert's principle basically comes in the dynamics portion of engineering mechanics. So, before starting off with the Dalembert's principle, first let us understand what do we mean by the term called dynamics, and then we will go to the principle of Dalembert's. Okay, so what is dynamics? We know that engineering mechanics is divided into two categories, and those two categories are statics and dynamics. What is statics? Statics is the study of the effect of force system acting on a particle or a rigid body which is at rest. Again, I repeat, what is statics? Statics is the study of the effect of force system acting on a particle or on a rigid body which is at rest. That means, say suppose I am having one particle or one rigid body, and if that rigid body is in rest condition, then on that rigid body how many forces are acting on it, and due to those forces what is the effect on that rigid body in rest condition, that is known as statics. And what is dynamics? It is the study of the effect of force system acting on a particle or on a rigid body which is in motion. It can also be stated as the study of geometry of motion with or without the cause of motion. Again, I repeat, what is dynamics? Dynamics is the study of the effect of force system acting on a particle or on a rigid body which is in motion. It can also be stated as the study of motion of a rigid body or a particle with or without the cause of motion. That means, say suppose I am having one particle or I am having one rigid body, and if that rigid body is in motion means the body is moving, then during that time what all forces act on that rigid body, or what are the effect of forces that acts on a rigid body during its motion is known as dynamics. This dynamics part is further subdivided into two types, and those two types are kinematics and kinetics. Again, I repeat, the dynamics is further classified into two types, and those two types are kinematics and kinetics. What is kinematics? It is the study of geometry of motion without the reference to the cause of motion. I repeat, what is kinematics? It is the study of geometry of a motion without considering the cause of motion. For example, in kinematics, mass and force are not considered. For example, say suppose I am having one body. That body is moving with a speed of say 4 meter per second. We are not concerned with the mass of the body, neither we are concerned with the external force acting on that body to move that body by speed of 4 meter per second. So when you won't consider the effect of mass and forces acting on a moving body, then that type of study comes under the category of kinematics. What is kinetics? It is the study of geometry of motion of a body with reference to the cause of motion. Again, I repeat, what is dynamics? Dynamics is the study of geometry of motion of a rigid body or a particle when you consider the cause of motion. That means, for example, say suppose I am having one body and that body is moving with a speed of 4 km per hour when you have applied an external force of 5 Newton on that body. See, in this example, due to the application of external force, the body is moving. That means here we are considering the cause of motion. Cause of motion means when you have applied a force on the body is moving with some velocity, with some speed. That is the cause of motion. So in kinetics, the mass and force, which are the cause of motion, are considered. But whereas in kinematics, cause of motion is not considered. We will say that simply a body is moving with, say, x meter per second or y kilometer per hour. We will not consider any external cause of motion such as mass or force acting on that body. And this Dalembert's principle comes in the dynamics part, and that too it comes under the category of kinetics. I repeat, D'Alembert principle comes under the dynamics part, and that too in the category of kinetics. Now let us understand what is D'alembert's principle. I hope my white screen is visible to you, in which I have written D'alembert's principle. What is D'alembert's principle? It states that the system of forces acting on a body which is in motion is in dynamic equilibrium with the inertia force of the body. Again, I repeat the statement of D'alembert's principle. What is D'alembert's principle? It states that the system of forces acting on a body which is in motion is in dynamic equilibrium with the inertia force of the body. Now, what is the meaning of the statement of D'alembert's principle? In order to understand the meaning of D'alembert's principle, let us consider one case. That case is, let us consider one body. This is that body. Okay. This body is subjected to a system of forces. Say suppose the body is subjected to an external force F1. Say the body is subjected to external force, say F2 over here. And say the body is subjected to an external force F3. External force F3, like this. Okay. Now the resultant of these three forces, which three forces? F1, F2, F3, which is acting on the body, will cause the body to move. I repeat, the resultant of these three forces, that is forces F1, F2 and F3, will cause the body to move along its direction with some velocity, with some acceleration, with some speed. Say suppose due to the external forces F1, F2 and F3 acting on this body, when we have taken the resultant of F1, F2 and F3, that resultant force, say that resultant force is F, resultant force of F1, F2 and F3, and that resultant force is making this body to move. Say suppose the body is moving in this direction with acceleration A. Say suppose the body is moving in this direction, which direction? In this direction with acceleration A. Then according to Dalembert's principle, this body can be made to remain static. According to Dalembert's principle, this body can be made to remain static if you apply a force equal to m into a. M into a means mass into acceleration, that acts in the reverse direction to the direction of motion of body. That means now due to the external forces F1, F2 and F3, the body will move in a certain direction. Say that body is moving in this direction with acceleration A. Now in order to make this body to remain static, what you need to do? You need to apply a force whose magnitude is ma in the opposite direction to the direction of motion of the body. That means this is that same body. On this body, the external forces F1 is acting like this, F2 is acting like this, and say F3 is acting like this. Now in order to maintain the static equilibrium of this moving body, according to Dalembert's principle, you need to apply a force of magnitude m into a in the direction opposite to the direction of motion of the body. Say due to force F1, F2 and F3, the body is moving in this direction. Then according to Dalembert's principle, if you want to keep the body in static equilibrium, you need to apply a force of magnitude equal to ma in the direction opposite to the direction of motion of the body. This is your Dalembert's principle. That means in order to keep this body in dynamic equilibrium, since we are talking about dynamics, so we will talk about dynamic equilibrium. Since in order to keep the body in dynamic equilibrium, the sum of the resultant of force F1, F2 and F3 should be exactly equal to the magnitude of the inertia force ma. This force ma, which we have applied in the direction opposite to the direction of motion of the body, in order to keep the body in static equilibrium, this force is known as inertia force. INERTIA. This force is known as inertia force, denoted by symbol Fi. That means in order to maintain dynamic equilibrium, according to Dalembert's principle, the force equilibrium equation will be summation of F is equal to 0. Summation of F for this body will be F1 plus F2 plus F3. Why all the three forces are positive? Because all the direction of all the three forces are in same direction. See, F1 is direction of force F1 is inward, direction of force F2 is inward, direction of force F3 is inward. So all the three forces will be positive. Say suppose if the one of the force or any two of the force direction is outward, then you have to take that force as negative. Either you take the inward force positive or you take the outward force negative. Okay. So according to this Dalembert's principle, in order to maintain the dynamic equilibrium of the body, the force equilibrium equation will be how much? It will be summation of F is equal to 0, and summation of F equal to 0 is what? It is F1 plus F2 plus F3 minus ma, because this inertia force is applied in the direction opposite to the direction of motion of the body. Minus ma is equal to 0. This will be the force equilibrium equation for a body satisfying Dalembert's principle. Or I can write it as F1 plus F2 plus F3 is equal to ma. What we have done, we have taken ma in the right hand side of the equation. Either you can write like this, or you can write like this, or you can write like this, that is F1 plus F2 plus F3 is equal to Fi. What is Fi? Fi is nothing but ma, and this Fi is known as inertia force of the body. What is m? M is the mass of the body, and what is a? A is the acceleration by which the body is moving. So this is all about Dalembert's principle. So now let us solve few problems related to Dalembert's principle. So whatever I have discussed so far, all these things are there in the slide. You can read from these slides whatever I have discussed so far. Okay. Let us solve the first problem based on Dalembert's principle. The problem is, determine the acceleration produced in a body of 50 kg mass when it is acted upon by a force of 125 Newton. Use Dalembert's principle. Again I repeat the question. Question is, determine the acceleration produced in a body of 50 kg mass when it is acted upon by a force of 125 Newton. Full stop. Use Dalembert's principle. Always remember that in engineering mechanics, it is not necessary that in all the problems you will be given the diagram. It is not necessary. ऐसा भी हो सकता है कि खाली प्रॉब्लम का स्टेटमेंट दिया गया हो आपको. You have to read that problem statement. Accordingly, you have to draw the diagram and then you have to solve the problem. If you see in this problem, diagram is not given to you. Only the statement of the problem is given to you. So what we will do is that we will, by reading the statement of the problem, we will draw the diagram and accordingly we will solve. Okay, so let us draw the diagram first. Okay, so what is the question? Question is determine the acceleration produced in a body of 50 kg mass. So that means we have to draw a body whose mass is 50 kg. Say suppose this is the body and the mass of the body is m is equal to 50 kg. Okay, what else is given? When it is acted upon by a force of 125 Newton, that means on this body a force of 125 Newton is applied. So let us apply a force of 125 Newton on this body. See, in this question the direction of 125 Newton force is not given to you. If it is not given to you, you are free to choose any direction. I have chosen this direction. Direction of force is along positive x-axis. Okay, what we need to find out? We need to find out the acceleration produced in this body. So that means we have a body whose mass is 50 kg and on this body an external force of 125 Newton is applied. Due to this 125 Newton force, the body will move. Say suppose the body is moving in this direction with acceleration A. And in this problem we need to find out the value of acceleration A. How we will solve it? So in order to solve the problem, let us draw the free body diagram of the problem. Let us draw the free body diagram of the problem. So क्या बोला गया है इस प्रॉब्लम में? एक बॉडी है. So this is that body, and on this body what has been applied? An external force of 125 Newton is applied. So ये लग गया 125 Newton का external force. Okay. Now due to this external force, what will happen? The body will move. Say suppose the body is moving in this direction. So this is the motion of the body. This is the direction of motion of the body. Okay. So the body is moving along positive x direction with how much acceleration? Say the body is moving with acceleration A. Okay. Now according to Dalembert's principle, if you want to maintain the dynamic equilibrium of the body, what you need to apply? You need to apply an inertia force of magnitude ma in the direction opposite to the direction of motion of the body. Since the body is moving along positive x direction due to this 125 Newton external force, so the direction of inertia force will be in this direction along negative x direction, and its magnitude will be inertia force Fy is equal to how much? It is m into A. What is m given in the problem? M कितना दिया हुआ है? 50 kg. So Fy will be 50 into A. Now let us write down the force equilibrium equation for this body. That is summation of F is equal to 0. Here I can see that in this body forces are acting along x direction only. So we will write summation of Fx is equal to 0. And what is summation of Fx equal to 0? It is 125 Newton acting in positive x direction minus inertia force Fy, and what is Fy? It is m into A, and what is m? It is 50 into A. No other forces are present along x direction. It will be equal to 0. So क्या बना equation? Equation जो बना है आपके पास, that is 125 minus 50 into A is equal to 0. or I can write it as 125 is equal to 50 into A, or acceleration A is how much? A is 125 by 50. How much it is coming? 125 by 50, it is 2.5 meter per second square. So this is the answer of the problem. क्या पूछा गया था क्वेश्चन में आपसे? पूछा ये गया था कि आपके पास एक बॉडी है, उस बॉडी का मास 50 केजी है, उस बॉडी पे एक एक्सटर्नल फोर्स एक्ट हो रहा है जिसका मैग्नीट्यूड है 125 न्यूटन. You need to find out the acceleration produced in the body due to that external force. तो जैसे ही आप बॉडी पे 125 न्यूटन का एक्सटर्नल फोर्स अप्लाई करोगे तो क्या होगा? बॉडी मूव करेगा with some acceleration. Say that acceleration is A. Then according to Dalembert's principle, in order to maintain the dynamic equilibrium, you need to apply an inertia force on this body in the direction opposite to the direction of motion of the body, and then you write down the force equilibrium equation and get the value of acceleration produced in the body. And the acceleration produced in the body is how much? It is 2.5 meter per second square. Very simple problem. Okay, chalo. So now next let us solve one more problem related to Dalembert's principle. So if you want, you can see the slides. Whatever I have discussed, it is there in the slides also. Okay, let us solve the next problem. The problem is a man weighing 750 Newton stands on the floor of a lift. Full stop. Determine the pressure exerted on the floor when the first part of the problem is lift moves upward with an acceleration of 2.5 meter per second square. Second part of the problem is lift moves downward with an acceleration of 2.5 meter per second square. Full stop. If 900 Newton pressure is to be exerted on the floor, comma, then with what acceleration the lift should move upward? Question mark. Solve the problem using Dalembert's principle. Okay. So what is given in the question? According to this question, there is a lift, and on this lift a man stands. Inside the lift there is a man whose weight is how much? The weight of the man is 750 Newton. What you need to find out? You need to find out the pressure exerted or the force exerted on the floor when the first part of the problem is lift move upward with an acceleration of 2.5 meter per second square. That means there is a lift. In that lift a man is standing whose weight is 750 Newton. Fine. So when the lift moves upward with some acceleration, how much is the pressure exerted on the floor of the lift? That you need to find out in the first part of the problem. And in the second part, when the same lift in which the man whose weight is 750 Newton is standing on the floor of the lift, when that lift moves downward with some acceleration, how much is the pressure that the man exerts on the floor? This you need to find out. The third part we will solve later on. So first of all, let us solve the first and the second part of the problem. Here also you can see that in this problem diagram is not given to you. So what you need to do? You need to read the problem line by line. Accordingly you will frame the diagram. So let us draw the diagram according to the given problem. So the first part of the problem, क्या बोल रहा है प्रॉब्लम में, एक लिफ्ट है. So let us draw a lift. Say suppose this is the lift. Okay, inside this lift there is a man standing on the floor of the lift. Let us draw it. Say suppose this is the man which is standing on the floor of the lift. Weight of the man is given to you, that is 750 Newton, and I know that weight will act vertically downward. So this is the weight of the man, capital W, that is equal to mg. Okay, fine. क्या बोला गया है क्वेश्चन में, यू नीड टू फाइंड आउट pressure or the force exerted on the floor of the lift by this man when the lift moves upward. That means in the first part of the problem, lift is moving upward. If the lift is moving upward, that means this is the direction of motion. This is the direction of motion of the lift. Lift is moving vertically upward. Fine. And the lift is connected by a cable. Let the tension exerted by the cable is how much? The tension exerted by the cable is nothing but T. Tension exerted by the cable is how much? It is nothing but T. So we need to find out what? We need to find out the pressure or the force that this man exerts on the floor of the lift. So we can use Dalembert's principle. According to Dalembert's principle, this lift is moving vertically upward. So in order to maintain the dynamic equilibrium of this lift, we need to apply an inertia force in the vertically downward direction, opposite to the direction of motion of the lift. So this is the inertia force Fi, and its magnitude is equal to m into a. It is equal to m into a. Okay, so if I write down the force equilibrium equation for this lift, what I will write? I will write summation of Fy is equal to 0, because all the forces are acting along y-axis only. Fine. So what will be summation Fy equal to 0? It will be plus T, because tension T is acting in positive y direction. I assume that vertically upward is positive y-axis and vertically downward is negative y-axis. Then it will be T minus weight of the man, that is mg, minus inertia force, that is Fi, that is Fi is equal to 0. What is T? T is the tension that in the cable supporting the lift, or the reaction of the lift, or the pressure exerted by the man on the floor of the lift. What is this T? T is nothing but the tension in the cable supporting the lift. भाई लिफ्ट तो हवा में तो लटकेगा नहीं, लिफ्ट को सपोर्ट करने के लिए एक केबल होगा, वो केबल ऊपर की तरफ जाएगा, केबल लिफ्ट को ऊपर की तरफ लेके जाएगा. फाइन. So what is T? T is the tension in the cable supporting the lift, or the reaction of the lift, because since the lift is standing on the ground will give a reaction to this lift in vertically upward direction, and that reaction is nothing but tension T, or it is nothing but the pressure that the man will exert on the floor of the lift. And in the first part of the problem, we need to find out this tension T. So how we will find out? We have the equation summation Fy equal to 0. It is how much? T minus mg minus Fi is equal to 0. Let us further solve this equation. What I can write? I can write T minus mg माइनस fi को मैं क्या लिख सकता हूँ, मैं fi को लिख सकता हूँ ma, m into a is equal to 0. Okay, minus mg and minus ma, let us bring it to the right hand side. Equation will be t is equal to mg plus ma, or I can write t is equal to m common in bracket g plus a. Okay, or I can write t is equal to, what is m? We know that weight of the man acting vertically downward is m into g. From this equation I can write m is equal to how much? M is w by g. So m is how much? M is w by g in bracket g plus a. What is a? A is the acceleration with which the lift is moving upward, and that a is given in the problem. It is 2.5 meter per second square. What is small g? Small g is acceleration due to gravity. Its value is 9.81 meter per second square. And what is w? W is the weight of the man, that is also given in the problem. It is 750 Newton. We will substitute all the values and we will get the value of tension T. So tension T is how much? Tension T is equal to W, कितना दिया है प्रॉब्लम में, that is 750 Newton by acceleration due to gravity is 9.81 in bracket small g is again 9.81 plus small a is acceleration. So lift is moving upward with an acceleration of how much? 2.5 meter per second square given in the problem. 2.5. Just solve this expression. You will get the value of tension T in the cable supporting the lift, or the pressure that the man will exert on the floor of the lift. How much is this tension T coming? Tension T is equal to 941.31 Newton. This is the first part of the problem. Okay, when the lift is moving upward with an acceleration of 2.5 meter per second. So the pressure that the man will exert on the floor of the lift is how much? It is 941.13 Newton. Now let us solve the second part of the problem. What is the second part of the problem? In the second part of the problem, you again need to find out the pressure or the force that the man exerts on the floor when the lift moves downward with an acceleration of 2.5 meter per second square. Okay, so this time what you need to do? This time in the second case, the lift is moving vertically downward. Remaining all the things are same. We need to find out tension T. So let us solve it. Second part of the problem. क्या बोल रहा है second part of the problem में? There is a lift. In this lift, a man is standing on the floor of the lift. This is that man. And the lift is moving vertically downward. So this is the motion of the lift. With some acceleration. How much is that acceleration? Given in the problem, it is 2.5 meter per second square. So let us draw the FBD of this lift. The weight of the man acting vertically downward, that is W is equal to M into G. Tension T in the cable supporting the lift will act vertically upward. This is the tension T. Now, in order to apply the Dalembert principle, or in order to keep this body in dynamic equilibrium according to Dalembert's principle, we need to apply the inertia force in the direction opposite to the direction of motion of this lift. So this will be the direction of inertia force Fi, which is equal to m into A. So now let us write down the force equilibrium equation for this lift, that is summation of Fy equal to 0, because forces are acting only in y direction. Now what is summation Fy equal to 0? It will be plus T acting in positive y direction minus mg, weight of the man acting vertically downward, minus plus inertia force, that is Ma, which is acting along positive y-axis, is equal to 0. Okay, now T will be equal to how much? T will be equal to mg minus Ma, or I can write T is equal to, we can take M common, so M in bracket it will be G minus A. Okay, or I can write T is equal to M. What I can write M from this equation? I can write M is equal to W by G. So substitute M by W by G in bracket G minus A. Okay, W given in the problem, that is how much? 750 Newton. So 750 by G. What is small g? Acceleration due to gravity. What is its value? 9.81. In bracket small g value is 9.81 minus acceleration with which the lift is moving vertically downward, given in the problem as 2.5 minus 2.5. So if you solve this expression, you will get the value of tension in the cable supporting the lift, or the pressure that the man exerts on the floor of the lift. So the tension T, how much it is coming? Tension T, it is coming out to be near about equal to 558.86 Newton. 558.86 Newton. This is the answer of the second part of the problem. Now let us solve the third part of the problem. So you can see in the slide also the second part is solved. This is the solution of the second part of the problem. So now let us solve the third part of the problem. So what is given in the third part? In the third part, if a 900 Newton pressure is to be exerted on the floor, then with what acceleration lift should move upward? So according to the third part of the problem, what is given? Tension in the cable supporting the tension in the cable supporting the lift, or the pressure exerted by the man on the floor of the lift is given. That means value of tension T is given as how much? 900 Newton. ठीक है, और क्या बोला गया है? Lift is moving upward. Lift is moving vertically upward. That means the inertia force will act vertically downward. So let us draw the diagram. Then we will write the force equilibrium equations, and what value we need to find out? We need to find out with how much acceleration lift is moving upward. That is the value A I need to find out in the last part of the problem. So let us solve it. So in the last part of the problem, there is a lift, and this lift is moving vertically upward. Lift is moving vertically upward by acceleration A. In the last part of the problem, tension in the cable supporting the lift or pressure exerted by the man on the floor of the lift, that is tension T is given. कितना दिया है tension T? That is 900 Newton. 900 Newton. Okay. Man is standing on the floor of the lift. This is the man which is standing on the floor of the lift. Weight of this man will act vertically downward. This is the weight of the man acting vertically downward. That is W is equal to mg. Clear? Now since the lift is moving vertically upward with acceleration A, then in order to maintain the dynamic equilibrium of this lift, I need to apply inertia force in which direction? Vertically downward direction. So this will be the direction of inertia force. Its value will be how much? Its value will be Fi is equal to Ma. Now we can write down the force equilibrium equation. Force equilibrium equation is summation Fy is equal to 0. Okay. What is summation Fy? It will be plus T minus mg minus Ma is equal to 0. This will be the force equilibrium equation along y-axis, or I can write what? I can write tension T is equal to mg plus Ma, or I can write tension T is equal to m. In common I can when you take m common, क्या बचेगा ब्रैकेट में? It will be g plus a. So tension T is equal to m is what? If I use this relation, m will be W by G. So W by G in bracket G plus A. In the last part of the problem, tension value is given to you. See, it is given that if 900 Newton pressure is to be exerted on the floor, that means this 900 Newton is tension in the cable supporting the lift. So tension T is 900 is equal to weight of the man. Weight of the man is given in the problem, that is 750 Newton. Weight of the man is 750 Newton by acceleration due to gravity. What is its value? We know it is 9.81. In bracket again G is 9.81 plus A. A we need to find out in the problem. Read the last line of the problem. It is written that with what acceleration the lift should move upward. That means A we need to find out in this problem. So plus A. So just solve this expression. You will get the value of acceleration A. And that A is how much? That A is 1.962 meter per second square. So this is the last part of the problem. You need to find out with how much acceleration lift is moving vertically upward. So lift is moving vertically upward with an acceleration of 1.962 meter per second square. So this is the complete solution of this problem. It's an easy problem. Only you need to understand the wording of the problem. Accordingly, you have to frame the diagram, draw the FBD, write the force equilibrium equations, apply the Dalembert's principle and get the answer. Okay, then with this I end my today's lecture over here. In the next lecture we will solve a few more problems related to Dalembert's principle. Thank you all.